Once upon a time, there was absolutely no sun, no planetary system, and no human life. The universe held nothing but an expansive expanse of swirling gas and cosmic dust. A massive solar nebula floated silently in the void. We are living here today simply because billions of years ago, there was a specific cosmic nebula that held every single one of the required elements. Everything that we observe in our cosmic neighborhood today was completely part of that original mixture of gas and space dust which made up our primordial solar nebula. Nearly 5 billion years in the past, a unique solar nebula was getting completely ready to give birth to our local star. So, what we have is this vast solar nebula made of gas and dust hanging around billions of years ago, yet it remains fundamentally unstable. What exactly causes the scale to tip and transforms a loose cloud of drifting gas into hard, solid celestial objects? Something major has to alter on the inside of a space nebula. A specific spark has to ignite the creation of stars and celestial planets. And that exact event continues to be a profound cosmic mystery. So, what is the true solution to this 5 billion year old galactic puzzle? There are two major competing ideas. Both of these concepts actually begin with ancient space fossils. These are physical fossils that travel all the way from the absolute outermost edges of our planetary system directly toward Earth, slicing violently through our planetary atmosphere and eventually finding their way right into our hands. Space meteorites are incredibly critical tools for us to analyze and inspect because they serve as literal time capsules from the exact era when our solar system was fundamentally first coming together. An expert named Meenakshi Wadhwa manages and curates one of the absolute biggest arrays of space meteorites on the entire face of the planet. These ancient space stones maintain an entirely pristine and untouched record of the earliest phases of our planetary system's history. There was absolutely nothing else existing in our immediate solar system before these specific stones were initially created. There was no planet Earth yet. There were no other celestial bodies orbiting around. It is completely mind-blowing to contemplate. The very first hard structures began to take shape out of a swirling cloud of particulate dust that completely surrounded our freshly born star. Space asteroids and falling meteorites developed at the exact same moment in time, meaning they still carry the unique chemical fingerprint of our original solar nebula. They truly hold some of the oldest physical materials, the earliest solid objects that separated and condensed out of that massive cloud of gas and dust, right as our planetary neighborhood was developing. Because of that, they gradually gathered together and constructed this massive, heavy rock that you're looking at right here. In the year 2017, a group of dedicated investigators analyzing the structural makeup of a specific category of stony space rock, known as chondrites, uncovered an essential clue regarding how our planetary ecosystem was originally created. There might actually be a literal smoking gun hidden somewhere deep within the chemical composition of these unique stones that could reveal to us exactly what occurred and how our entire solar system was brought into being. This specific smoking gun turns out to be a highly volatile radioactive element called iron-60, and it is widely believed to be generated exclusively within the explosive hearts of giant supernovas. If you happen to have a large nebula that is sitting there completely prepared to begin generating stars, and a massive supernova suddenly detonates right next door to it, that exploding star is going to instantly release and dump all of those heavy, complex elements directly into the nearby gas cloud. However, that explosion is also simultaneously going to spark the quick creation of stars by crashing violently into that drifting gas and heavily squeezing it together. A nearby stellar neighbor suffers a cataclysmic supernova explosion. The intense shock wave collides directly with our local solar nebula, injecting a heavy amount of iron-60 straight into it. Yet this violent impact immediately initiates a completely unstoppable, runaway gravitational collapse deep inside the core of the nebula. The massive gas cloud begins to gather together in heavy clumps, growing incredibly hot and exceptionally dense. Our central sun is officially born, Right as the Sun is coming into existence, there is fundamentally a massive ring of cosmic debris and junk scattered all around the newborn star. As this material continuously travels in orbit around the Sun, it essentially gathers together or clumps up, expanding gradually into these large round spheres. Throughout the course of the subsequent 100 million years, these orbiting spheres continue to grow significantly larger and heavier, ultimately constructing asteroids, moons, and full-scale planets. Every single one of the planets inside our solar system looks entirely distinct from the others. We have massive ice giants, large gas giants, and solid rocky worlds. But the reality is that every single one of these unique worlds originated directly from the exact same primary solar nebula. And right on one tiny specific planet, the absolute perfect blend of chemical elements eventually gave rise to human existence. Absolutely everything, every single atom inside our physical bodies was once a small part of that original solar nebula. The specific concept that a nearby supernova explosion gently nudged our entire planetary system into existence is highly persuasive, yet not every single scientist agrees with this path. Sometimes the absolute biggest debates and arguments among professional scientists are triggered by the smallest imaginable items. In this particular scenario, I am referring to tiny, minuscule radioactive atoms. In the year 2017, separate scientific investigations revealed that an entirely different group of meteorites held an entirely distinct radioactive signature, which was a rare isotope of aluminum known specifically as aluminum-26. That is an extremely unusual type of atom that is simply not created very easily inside standard supernova explosions. Consequently, that material had to originate from a completely different cosmic source. That alternative source is an incredibly rare category of massive star that holds 40 to 50 times the total mass of our own Sun, known as a Wolf-Rayet star. Extreme stars can be incredibly bizarre objects, and the stars that possess the most massive weights are exceptionally weird. The largest classification of star that humans have ever discovered is what astronomers call a Wolf-Rayet star. Wolf-Rayet stars burn at the absolute highest temperatures of any stars in the cosmos, generating heavy structural elements like aluminum-26 throughout their brief, intense lives. These objects are incredibly massive, exceptionally hot, highly luminous, and they continuously emit an incredibly powerful stellar wind. This intense stellar wind forcefully drives tons of physical material away from the star and out into the empty space around it, creating a distinctive bubble-like formation. Astronomers can view this exact cosmic mechanism currently functioning inside the famous Bubble Nebula, located roughly 7,000 light-years away from Earth. Right in the dead center of that nebula sits one of these colossal stars emitting a powerful stellar wind, sending out high-energy particles and intense radiation, and exactly as its name implies, it is literally blowing a massive bubble inside the larger cloud of nebular material surrounding it. The protective outer walls or casing of this bubble are exceptionally thick and completely packed with physical matter. The powerful stellar wind continuously forces more and more material directly into the outer shell, until this gathered material completely collapses under its own immense gravity and condenses down into fresh stars. It is completely possible that the exact process we are witnessing over in the Bubble Nebula is precisely what took place right here 4.5 billion years ago or even longer to create our Sun and the surrounding planets. If our local solar system actually developed inside the protective pocket of a Wolf-Rayet Bubble Nebula, it would perfectly clarify the reason why such a massive amount of aluminum-26 is actively present inside our ancient meteorites. However, the scientific community has still not reached a final verdict. What we absolutely know for certain is that our entire cosmic tale initiated with the sudden collapse of that original solar nebula. But one inevitable day, our local star will pass away. Will our Sun transform into a breathtaking, colourful nebula, or will it simply diminish and fade completely to black? In August of the year 2017, the Cassini robotic spacecraft successfully recorded 6 distinct photographs of Enceladus, which ranks as one of the absolute most captivating and intriguing moons in our entire solar system. Enceladus is a comparatively tiny moon orbiting Saturn that is honestly quite easy to completely overlook, but the moment you truly focus your attention on it, it presents an incredible variety of shocking surprises. We have recognized that something was highly unusual regarding this freezing, icy world ever since the historic Voyager space mission captured detailed photographs of it back in 1980. We completely assumed that Enceladus would be frozen entirely solid all the way through, and yet we discovered from the retrieved Voyager data that the exterior surface of Enceladus was a brilliant radiant white, and we could easily observe on the terrain that massive stretches of the landscape were incredibly smooth, at least at the specific level of detail we could see using the Voyager cameras. That observation immediately indicates that there has been significant internal geological activity taking place, because on a moon with no atmosphere, that is truly the only known mechanism that could completely erase impact craters. Space scientists strongly suspected that some unknown force was actively altering and resurfacing the exterior of Enceladus, continuously filling in its deep craters to make the surface look incredibly smooth and highly reflective. Later on, the Cassini spacecraft transmitted back stunning photographs of Enceladus lit from behind, and the entire mystery was completely unveiled to the world. We witnessed these massive icy streams of material shooting directly out from Enceladus, and everyone was completely stunned that a moon so incredibly small and universally assumed to be a completely frozen solid block of ice could be so intensely active. We saw massive sprays of practically glowing material shooting out from active surface geysers. When I personally viewed a photograph of a geyser erupting on Enceladus for the very first time, I was completely stunned. That is absolutely incredible. I had absolutely no clue that something like that was even physically possible. The incredible Cassini discovery of active geysers on Enceladus completely changed the entire scientific game. All of a sudden, right before our eyes, liquid water was actively jetting out into space. It felt almost too incredible to actually be real. The Cassini probe revealed that these geysers are forcefully discharging real liquid water. Enceladus is definitively not just a solid dead sphere of ice. As we gathered additional information from the Cassini mission, we discovered that Enceladus possessed a distinct physical wobble that was far too massive for a celestial body that was frozen solid through its entire center. That vital clue informed us that a massive liquid water ocean completely encircled a solid rocky core. Enceladus maintains real liquid water directly beneath its outer surface, and it may very well be a massive ocean completely enveloping the entire interior of that celestial moon. But where exactly is all of this internal heat originating from? When new planets and moons initially form, their interior cores are incredibly hot. However, over vast stretches of time, they naturally cool down completely. The smaller the overall celestial body is, the quicker it loses its heat. A tiny, minuscule world like Enceladus, positioned more than 1 billion miles away from the heat of the Sun, should have frozen completely solid a very long time ago. That is precisely what we logically anticipated. If celestial objects are small, then they should be completely dead geologically and heavily covered in impact craters. Yet, Enceladus proves to us that this assumption is completely incorrect. How could an incredibly tiny moon located so far away from the Sun possess enough internal warmth to maintain liquid water? One prominent explanation is a process known as tidal heating. If you have ever played a fast-paced game of racquetball, you know firsthand that as you play the match, the ball gets noticeably warmer. This occurs because every single time the ball crashes into the racket or the wall, it gets physically compressed and squeezed, and then it immediately expands back to its normal shape. The immense gravity of Saturn continuously compresses and relaxes Enceladus as it travels along its orbital path around the ringed planet, heating up its core much like a compressed racquetball. However, this specific process by itself would not create nearly enough thermal energy to prevent Enceladus's underground water from freezing completely solid. Something else entirely must be taking place deep inside the Moon's core. What if the interior core of Enceladus is actually somewhat loose and gravel-like? Instead of it being a single solid block, it is actually composed of a loose collection of rocks, pebbles, and coarse gravel all packed together. If that is the case, then what happens is that as the immense gravitational tides stretch and squeeze the Moon, those internal rocks are continuously rubbing directly against each other, and that friction actually creates an even greater amount of thermal energy. In the year 2017, an advanced computer simulation built on actual Cassini data revealed that this internal tidal friction creates more electrical energy than the absolute biggest power plants located in America. Underground water heated up to an impressive 194 degrees Fahrenheit naturally rises toward the frozen surface. It forcefully sprays through deep fractures in the Moon's southern polar region, generating massive misty plumes in space. As our spacecraft flew directly through these plumes 7 separate times to taste and inspect the gas and drifting particles, we discovered salty particles indicating that the hidden ocean was highly saline, very much like the oceans found on Earth. We detected hydrocarbons, methane, carbon dioxide, and ammonia. We discovered the essential structural ingredients required for life shooting directly out from the geysers of Enceladus. It is so completely extraordinary. In the year 2018, researchers completely re-examined the gathered Enceladus data and uncovered something even more astonishing: complex organic molecules. What they identified were significantly larger organic structures than what anyone had initially anticipated finding there. At the start, it appeared to be nothing but dust, water, and some fundamental organic material. Now, they're identifying far more intricate materials emerging directly from the deep interior of Enceladus. And that raises the ultimate question: what else is currently living down there? On our own planet, we find living organisms clustered tightly around scalding thermal vents on the dark ocean floor. Could the exact same scenario be occurring inside the hidden seas of Enceladus? Could these complex organic structures be definitive indicators of alien life? My absolute favourite descriptive term for them is organic goo. They are thick, gooey substances, and you can think of biological life itself as a complex arrangement of these gooey molecules. Now, that does not mean that every single gooey molecule is strictly biological in origin, but biological systems certainly utilize these complex organic molecules to function. Deep within the subsurface oceans of Enceladus, intense heat rising from hydrothermal vents actively triggers complex chemical reactions. This process combines basic, simple molecules like methane and hydrogen into much longer complex organic structures, intricate molecules that could easily function as the primary precursors for biological life. What is truly mind-blowing is the fundamental chemistry occurring inside that ocean. Every single thing required to spark life is actively present. The eternal question we face is whether life exists elsewhere in the cosmos, and Enceladus is an absolute prime location to try and solve that mystery. Furthermore, the Cassini mission unveiled the deep secrets of an entirely different moon of Saturn that possesses incredible chemical properties. It is a colossally large moon featuring Earth-like landscapes, including flowing rivers, expansive lakes, and sweeping sand dunes. Titan. In September of the year 2017, just 4 days before its long mission finally concluded, the Cassini probe soared past one of Saturn's absolute most magnificent moons, Titan. Here is the exact reason why I personally love Titan. It is not merely due to the fact that it possesses a grand name that translates to big and strong, which naturally makes you think of an individual like me, but because it holds an incredibly expansive atmosphere that is composed mostly of nitrogen, which is exactly like the atmosphere of our own Earth. Titan has always been a deep enigma. What exactly is lurking beneath that incredibly dense, hazy atmosphere? When viewed through a standard telescope, this moon appeared to be nothing more than a blurry, featureless orange sphere. Then, the Cassini mission deployed the specialized Huygens probe. This probe traveled directly beneath the thick cloud layers and transmitted back the very first images of Titan's hidden surface. I almost cannot fully articulate how incredibly breathtaking it was to witness. The successful landing of the Huygens probe directly onto the terrain of Titan felt exactly like a classic Jules Verne sci-fi adventure coming to life. The panoramic images that you view as you're dropping through the alien atmosphere reveal a world that suddenly comes into focus, and it is this absolutely stunning environment that appears incredibly familiar to our eyes. You see prominent mountains and these distinct river streams draining directly into a massive ocean. Wow! You could be standing right on the edge of a vast lake, but this specific lake does not consist of regular water. Instead, the liquid is pure methane, making it appear much darker. It is an incredibly cold, utterly bizarre environment, with physical geological formations that appear recognizable, yet they are set in an incredibly alien landscape. Titan is truly like a home away from home, except it happens to be colder by roughly 350 degrees Fahrenheit. The historic Cassini mission revealed to us that Titan is practically identical to Earth when it comes to its surface topography. In fact, nearly 1/4 of the entire moon is completely covered in massive sand dunes, which is exactly like the desert landscape you see right behind me. Yet, the Cassini probe reveals that Titan's desert dunes are absolutely not what they appear to be on the surface. The sweeping dunes discovered on Titan are composed of a substance that is entirely different from the sand dunes found on Earth. We know that the vast majority of sand on Earth is composed of quartz particles. However, on Titan, the massive sand dunes are composed entirely of organic materials. Titan's sand grains are formed from microscopic particles of organic debris, a substance often described as hydrocarbon gunk. Meanwhile, the massive gas giant Jupiter contains critical keys to unlocking the deep mysteries of our entire planetary system. In the year 2011, NASA successfully launched a billion-dollar space mission designed explicitly to uncover them. 3, 2, 1 ignition, and a successful liftoff of the powerful Atlas V rocket, carrying the Juno spacecraft on a historic journey directly toward Jupiter. To successfully reach its destination, the Juno probe must set out on a challenging 5-year voyage across space. Directing any robotic spacecraft to a completely different planet is always going to be an exceptionally difficult task, but launching one specifically to Jupiter is truly pushing our technological boundaries to the absolute limit. Juno carefully navigates through the solar system with an incredible level of mathematical accuracy. The spacecraft constantly fights against extreme temperature swings and carefully steers its way through the dense asteroid belt. If a single tiny speck of dust happens to cross your orbital path, and that material impacts your spacecraft at high speeds, it can inflict a catastrophic amount of structural damage. After travelling a staggering 1.7 billion miles throughout its mission, the Juno probe finally approaches its target destination. However, the robotic probe is currently speeding toward Jupiter at an incredible velocity of 165,000 miles per hour. Juno is travelling exceptionally fast, making it one of the absolute speediest spacecraft ever constructed by humanity. You must move fast enough to actually reach the destination in a reasonable time frame, but then you must slow down sufficiently to allow the intense gravity of that planet to capture you. You have to execute the maneuver flawlessly. Successfully entering a stable orbit around Jupiter represents the absolute most dangerous and complicated phase of the entire mission. Make a single error, and Juno could crash violently straight into the planet, or it could skip off the atmosphere and drift aimlessly into deep space. Successfully getting Juno to settle into a permanent orbit around Jupiter is practically identical to shooting a basketball all the way from London and having it land perfectly on the front rim in New York City, sitting there entirely balanced without falling. I could personally achieve that, but could the engineers at NASA pull it off with the Juno spacecraft? Fortunately, NASA has an exceptionally clever game plan ready. Juno executes a complete backflip maneuver in open space and fires its main thruster engine directly toward Jupiter. Everything is proceeding completely according to plan. We are continuously firing the engine and successfully altering our forward velocity. The rocket engine burns continuously for 35 incredibly stressful minutes, successfully dropping the spacecraft's overall speed by 1,200 miles per hour. At long last, the robotic probe successfully achieves a stable orbit around Jupiter. Right on the 4th of July, right during the holiday fireworks, we successfully entered our planned orbit. In many real ways, because we are firing our massive rocket motor, it is a spectacular display of cosmic fireworks. The incredible Juno spacecraft is now safely operating in its planned orbit. The scientific instruments are completely powered up, and they are preparing to peer directly beneath the dense, swirling cloud decks of the giant planet. What we are truly searching for are the deep secrets of how this massive world was originally constructed. Yet, to successfully gather that vital data, Juno must repeatedly dive through a highly radioactive field that is completely filled with lethal, invisible energy. It is a terrifying environment. The immediate space surrounding Jupiter is a chaotic zone of extreme radiation that can easily fry ordinary electronics in a matter of seconds. This happens because Jupiter possesses an incredibly powerful magnetic field. It is the absolute biggest magnetic field of any planet in our solar system, and it acts like a giant particle accelerator, trapping high-energy electrons and whipping them around at nearly the speed of light. If those fast-moving particles strike the delicate computer chips inside Juno, the mission is completely over. To survive this onslaught, engineers built a heavy vault made of solid titanium to protect the spacecraft's electronic brain. This protective shielding is absolutely essential, but even with it, Juno cannot stay in the high radiation zone for too long. Because of that, the spacecraft travels along an incredibly elongated oval-shaped orbit. It spends most of its time far away from Jupiter, in the relative safety of deep space, and then it suddenly sweeps down, skimming just a few thousand miles above the colourful cloud tops for a very brief period, before racing back out to safety. During these close passes, Juno's highly advanced scientific instruments record data that completely shatters our previous understanding of Jupiter. For a long time, we pictured Jupiter as a neatly layered planet with smooth, uniform bands of wind circling the globe. We assumed that beneath the top clouds, everything would be relatively calm and predictable. But the data reveals a completely different reality. The deeper layers of Jupiter are a chaotic mess of giant, twisting cyclones and violent storms that stretch thousands of miles down into the interior of the planet. Even more shocking is what Juno discovered about Jupiter's deep core. For decades, planetary scientists debated whether Jupiter possessed a solid, rocky core or if it was composed entirely of dense gas all the way to its absolute centre. The latest gravitational readings indicate something entirely unexpected. The core is not a sharp, solid sphere at all. Instead, it is a fuzzy, diluted core that seems to be partially dissolved and spread out across a massive portion of the planet's deep interior. This strange discovery suggests that early in the history of our solar system, something truly catastrophic must have happened to Jupiter. A prominent explanation is that a colossal protoplanet, a world many times the size of Earth, slammed directly into Jupiter during the chaotic era of planet formation. This massive impact would have completely shattered Jupiter's original rocky core, mixing it thoroughly with the surrounding liquid hydrogen, and creating the strange, spread-out core that Juno detects today. While Jupiter reveals secrets about our solar system's violent past, another planet in our cosmic neighbourhood is teaching us about the fragile nature of planetary atmospheres. Mars is a cold, barren desert world today, but it was not always this way. Billions of years ago, Mars was a warm, wet planet with thick clouds, flowing rivers, and potentially vast oceans covering its northern hemisphere. It looked remarkably similar to early Earth. So, what exactly went wrong? How did a world that was once so rich in liquid water transform into a frozen, dead wasteland? The ultimate answer to this mystery is currently being uncovered by a specialized spacecraft orbiting the red planet, known as MAVEN. The main mission of the MAVEN probe is to study the upper atmosphere of Mars and figure out exactly how it lost its air. The primary culprit behind the destruction of the Martian atmosphere is the Sun itself. Our star continuously emits a powerful stream of charged particles known as the solar wind. This wind races through the solar system at incredible speeds, slamming into every planet in its path. On Earth, we are completely protected from this destructive force by our planet's powerful magnetic field, which acts like an invisible shield, deflecting the solar wind safely around us into deep space. Mars, however, does not possess a global magnetic field today. It lost its internal magnetic shield billions of years ago when its core cooled down and stopped churning. Without that protective barrier, the Martian atmosphere was left completely exposed to the harsh solar wind. The high-energy particles from the Sun began to crash directly into the gas molecules in the upper atmosphere of Mars, literally stripping them away and throwing them out into the void of space. The MAVEN spacecraft has actually watched this destructive process happening in real time. The data shows that the solar wind is continuously stealing gas from Mars at a rate of about several pounds every single second. During intense solar storms, when the Sun erupts with massive solar flares, this atmospheric erosion speeds up dramatically, stripping away massive amounts of air in a very short time. Over billions of years, this continuous stripping completely thinned out the Martian atmosphere, causing the surface water to evaporate or freeze solid, and ruining any chance the planet had of maintaining a warm climate. But our exploration of the cosmos does not stop at the edge of our solar system. When we look far beyond our neighbouring planets, we begin to see the true structural framework of the entire universe. For a long time, astronomers believed that galaxies were just scattered randomly throughout the empty void of space, like drifting islands in a vast, featureless ocean. But modern deep space surveys have revealed that the universe actually possesses a magnificent, interconnected structure known as the cosmic web. The cosmic web is a truly colossal network made of long, thin filaments of gas and dark matter that stretch across billions of light years. Galaxies are not isolated. They are clustered tightly along these massive filaments, like glowing beads strung along an invisible thread. Where these giant filaments cross paths and intersect, massive superclusters of thousands of galaxies are formed. In between these crowded filaments lie truly immense empty voids where practically nothing exists. This grand cosmic structure is the largest physical thing in the known universe, and its origins trace all the way back to the very beginning of time. To truly understand how this web was woven, scientists must use advanced computer simulations to model the history of the cosmos, starting from the Big Bang. These simulations reveal that the shape of the cosmic web was originally determined by tiny, microscopic ripples in the density of the early universe. Right after the Big Bang, the universe was an incredibly hot, dense soup of energy and subatomic particles. It was almost perfectly smooth, but not quite. There were incredibly tiny fluctuations, areas that were just a fraction of a percent denser than the surrounding space. As the universe rapidly expanded, gravity began to work on these tiny irregularities. The regions that had slightly more mass pulled in more and more material from the surrounding areas, growing heavier and more powerful over time. This gravitational runaway process eventually pulled the matter of the universe into the long, stretching filaments we observe today, while the emptier regions became the vast cosmic voids. But standard matter, the regular gas and dust that we can actually see, does not possess enough gravitational strength to build this massive structure on its own. There must be an additional invisible ingredient that provides the primary structural scaffolding for the cosmic web: dark matter. Dark matter is one of the most profound mysteries in all of modern science. It is a completely invisible form of matter that does not emit, absorb, or reflect any light, making it entirely impossible to detect with traditional telescopes. Yet, we know it is definitely out there because we can easily observe its immense gravitational influence on the visible universe. It outweighs regular matter by a factor of 5 to 1. Without the massive gravitational pull of dark matter, the regular gas and dust in the early universe would have simply drifted apart as the cosmos expanded. There would not have been enough gravity to pull matter together to form the first stars, galaxies, or the cosmic web itself. Dark matter acted like an invisible cosmic glue, creating deep gravitational wells that pulled regular matter in, forcing it to clump together and ignite into the very first galaxies. To map out this invisible structural backbone, astronomers use a clever technique called gravitational lensing. When light from a very distant galaxy travels through space toward Earth, its path gets physically bent and distorted by the gravity of any heavy matter it passes along the way, including dark matter. By carefully analysing these tiny distortions in the shapes of millions of distant galaxies, scientists can construct detailed three-dimensional maps of where the invisible dark matter is concentrated, revealing the true hidden shape of the cosmic web. At the same time, we are discovering completely new ways to listen to the active universe. In the year 2015, humanity achieved a massive technological breakthrough by detecting gravitational waves for the very first time in history. This monumental discovery opened up an entirely new window into the cosmos, allowing us to sense the universe through ripples in the fabric of space-time itself. Gravitational waves were originally predicted by Albert Einstein in his famous theory of general relativity over a century ago. Einstein calculated that when incredibly massive objects accelerate through space, they should literally create ripples in the fabric of space and time, much like a boat creating waves as it moves through water. But because space is incredibly stiff and rigid, these ripples are unimaginably tiny by the time they reach Earth, making them almost impossible to detect. To catch these elusive waves, scientists constructed an incredibly sensitive instrument known as LIGO, the Laser Interferometer Gravitational Wave Observatory. LIGO consists of two massive L-shaped facilities located thousands of miles apart in Washington and Louisiana. Each facility features two perpendicular tunnels that stretch for 2.5 miles. A powerful laser beam is split in half and sent down each tunnel, bouncing off mirrors at the far ends and returning to a central detector. If a gravitational wave passes through the facility, it will physically stretch one tunnel by an incredibly tiny amount while compressing the other tunnel. This minute change alters the distance the laser light travels, creating a distinctive pattern at the detector. The scale of this measurement is completely mind-boggling. LIGO must detect a shift that is thousands of times smaller than the total width of a single atomic nucleus. The very first gravitational wave ever detected was generated by a cataclysmic event that took place over 1 billion light-years away, the violent collision and merger of two massive black holes. These two monstrous objects, each holding dozens of times the mass of our Sun, whirled around each other at nearly the speed of light before crashing together into a single, larger black hole. The sheer energy released by this collision was greater than the light emitted by all the stars in the visible universe combined. Yet it reached Earth as a tiny, subtle whisper in space-time. Since that historic first detection, gravitational wave astronomy has advanced at an incredible pace. In 2017, scientists achieved another spectacular milestone by detecting the collision of two neutron stars, which are the incredibly dense, collapsed cores of giant stars that have died. Unlike black holes, which emit absolutely no light, the collision of neutron stars produces a massive explosive flash of radiation across the entire electromagnetic spectrum. This historic event, known as a kilonova, was observed simultaneously by gravitational wave detectors and dozens of traditional telescopes around the world. The data gathered from this single event solved a long-standing cosmic mystery, by proving that these violent cosmic collisions are the primary source of the universe's heaviest chemical elements, including gold, platinum, and uranium. Every single piece of gold jewelry on Earth was literally forged in the violent collision of neutron stars billions of years ago. As we look further back into the history of the cosmos, we eventually reach the absolute limit of what traditional telescopes can observe. This boundary is marked by a faint, fading glow that fills the entire sky, known as the cosmic microwave background radiation. This ancient light is the literal afterglow of the Big Bang itself, and it holds the ultimate record of how our universe began. For the first 380,000 years after the beginning of time, the universe was so incredibly hot and dense that it was completely opaque. It was a thick, glowing plasma of electrons, protons, and high-energy light. Because the free electrons were constantly scattering the light particles, light could not travel any real distance without crashing into something. The entire universe was like a thick, glowing fog, and it was entirely impossible for light to escape or travel freely through space. But as the universe continued to expand, it naturally cooled down. Eventually, the temperature dropped to a point where the free electrons could finally combine with protons to form the very first stable atoms of hydrogen gas. This historic moment is known as recombination. With the free electrons suddenly locked away inside atoms, the cosmic fog instantly cleared, and the trapped light was suddenly free to travel across the cosmos unimpeded. The universe became completely transparent for the very first time. That ancient light has been travelling through space ever since for over 13 billion years. As the universe expanded over time, the fabric of space itself stretched, and that ancient light was stretched along with it, shifting its wavelength out of the visible spectrum and down into the microwave region of the radio spectrum. Today, this light is completely invisible to human eyes, but specialized space telescopes can capture it, providing us with a stunning, detailed photograph of the infant universe. By carefully mapping out the tiny temperature variations in this ancient light, scientists can determine the precise age, composition, and ultimate fate of our universe. It reveals a cosmos that is exactly 13.8 billion years old, composed mostly of dark energy and dark matter, with regular matter making up just a tiny fraction of the total mixture. It is the ultimate blueprint of reality, showing us the exact starting conditions that eventually led to the creation of the cosmic web, the first galaxies, and eventually our own solar system. The ancient cosmic microwave background radiation offers us a definitive image of the infant universe, a perfect snapshot from a time long before the very first stars ignited. But as the universe continued to grow older and expand further, it entered a long, dark era that astronomers call the Cosmic Dark Ages. During this ancient period, there was absolutely no visible light in the entire universe. There were no bright stars shining, no glowing galaxies spinning, and no fiery supernovas exploding. The entire cosmos was just a cold, dark, silent void, filled with uniform clouds of neutral hydrogen and helium gas drifting aimlessly through space. This dark period lasted for hundreds of millions of years, but underneath the absolute darkness, an invisible force was working tirelessly to reshape reality. Gravity was constantly pulling the drifting gas molecules closer and closer together, focusing on the tiny density fluctuations that had been left behind by the Big Bang. The invisible scaffolding of dark matter acted like a massive gravitational trap, gathering regular hydrogen gas into increasingly dense, heavy pockets. As these massive gas clouds grew heavier, their internal gravitational pull became incredibly intense, dragging more and more material into their centers and causing the gas to compress and heat up dramatically. Eventually, the temperature and pressure at the absolute center of these collapsing gas clouds reached an unimaginable tipping point. The conditions became so intensely hot and pressurized that nuclear fusion was officially triggered, forcing simple hydrogen atoms to smash together and forge completely new helium atoms, while simultaneously releasing an immense burst of pure energy. The very first stars in the universe were officially born, piercing the cosmic dark ages with brilliant points of light. These pristine native stars were completely massive, holding hundreds of times the total mass of our own Sun, and they burned through their nuclear fuel at an incredibly rapid, furious pace. The birth of these stellar giants initiated a major era in cosmic history known as the Cosmic Dawn, or the Ryanization Epoch. The intense ultraviolet radiation pouring out from these magnificent newborn stars was so incredibly energetic that it began to tear through the surrounding neutral hydrogen gas, stripping electrons away from protons and ionizing the gas across the entire universe. This dramatic transformation cleared away the remaining cosmic fog, making the universe completely transparent to visible light and setting the stage for the creation of the very first complex galaxies. When we observe these ancient early galaxies using our most powerful space telescopes, we discover that they look entirely different from the majestic, orderly spiral galaxies we see in our modern cosmic neighborhood today. The earliest galaxies were small, chaotic, irregular clumps of stars and gas that were constantly colliding and merging with one another. They were incredibly unstable ecosystems, violently churning out new generations of stars while simultaneously being torn apart by frequent supernova explosions. Over billions of years, these small, messy proto-galaxies repeatedly crashed into each other, gradually gathering enough mass and structure to build the massive, elegant galaxies like our own Milky Way. Deep within the core of practically every single large galaxy that exists today lies a monstrous object that plays a critical role in its evolution, a supermassive black hole. These gravitational titans can hold millions or even billions of times the total mass of our Sun, compressed down into an incredibly small region of space. For a very long time, astronomers faced a major chicken and egg dilemma. What came first? The massive galaxy, or the supermassive black hole at its centre? Did a galaxy gather its stars first and then develop a black hole at its core? Or did a massive black hole form first and use its immense gravity to pull a galaxy together around it? Modern space observations and advanced computer models have finally revealed that the two entities actually grow and evolve together in a beautiful, highly coordinated cosmic dance. As a galaxy pulls in fresh gas from the surrounding cosmic web, a significant portion of that material spirals directly down into the central black hole, causing it to grow rapidly. But as the black hole consumes this material, it generates an immense amount of energy, blasting powerful jets of radiation and high-speed particles far out into the surrounding galaxy. This intense feedback loop can heat up the galaxy's gas clouds, temporarily preventing them from collapsing to form new stars and effectively regulating the overall growth of the galaxy. This delicate cosmic balance is exactly what allowed our own solar system to eventually form in a peaceful, quiet neighborhood of the Milky Way. But our ongoing exploration of the deep universe constantly reveals new anomalies that challenge our neat, structured models of planetary science. For instance, when we turn our attention back toward the planets inside our own solar system, we discover that even the cold, barren worlds like Mars are still holding on to deep, liquid secrets that completely defy our standard expectations. In recent years, advanced radar instruments operating on robotic spacecraft orbiting Mars have transmitted back data that shock the entire scientific community. By bouncing low-frequency radio waves directly through the southern polar ice cap of Mars, scientists detected a highly reflective signal coming from deep beneath the frozen surface. On Earth, this specific type of bright radar reflection is only observed when the radio waves strike a body of real liquid water, such as the subglacial lakes hidden deep beneath the thick ice of Antarctica. This incredible discovery strongly suggests that liquid water lakes are actively existing on Mars today, buried safely beneath more than a mile of solid ice. But this immediately presents an incredible scientific puzzle. Mars is an exceptionally cold planet, and the temperature beneath its polar ice cap is far below the normal freezing point of regular water. How could a lake possibly remain liquid in such a freezing, hostile environment? There are two major explanations currently being debated by experts. The first possibility is that Mars is not entirely dead geologically. It is completely possible that pockets of active magma or residual volcanic heat are still lingering deep within the Martian crust, warming the subglacial ice from underneath and preventing it from solidifying. The second, highly probable explanation involves a specific chemical ingredient: salt. If you have ever spread rock salt onto a frozen, icy driveway during a cold winter day, you have witnessed this physical process in action. The moment the salt contacts the ice begins to melt. Salt water possesses a significantly lower freezing point than fresh, pure water, allowing it to remain completely liquid at temperatures well below zero. The hidden lakes of Mars are likely incredibly salty brines, packed with perchlorate salts that act like a natural antifreeze. While we're still not entirely certain if these features are completely liquid lakes or dense deposits of frozen muddy clay, they represent one of the absolute best environments to search for potential microbial life on Mars today. From the pristine nebula that originally gave birth to our Sun, to the hidden oceans of Enceladus, the hydrocarbon sand dunes of Titan, the shattered fuzzy core of Jupiter, the stripped atmosphere of Mars, and the grand architecture of the cosmic web itself, our universe is a magnificent, deeply interconnected tapestry of matter and energy. We are completely a part of this grand cosmic story, built from the exact same atoms that were forged in ancient stars and pulled together by the unyielding laws of gravity.